I'm going to dive right in with a brand new Overleaf project. I recommend using Overleaf because it's sort of the Google Docs of LaTeX. It makes it really easy to store to the cloud, start new projects, and share it with other people. When you create a blank project in Overleaf, what you get is this, not exactly blank, but it sets you up with all the bones that you'll need for your document. And let's go through what we're seeing here. On the left, we see a pane of plain text where we actually type our LaTeX document. And on the right, you can see the rendered example that comes up. And every time we change something on the left, we will hit recompile to show the result on the right. Let's go line by line and see what each of these different commands does. So in LaTeX, a command starts with a backslash like this. And then there will be a given name for a command. The first command is always document class. This tells LaTeX what kind of document you're writing. We're going to start with article, and later on I'll show you what happens when you change the document class. The next command here is a use package command. You can think of this as an import function in programming where you are calling a particular set of commands that allows your document to have additional functionality. In this case, we are importing the package GraphicX, which is extremely common and probably something you'll want to import in every single document that you create because it allows you to insert images. Next to the use package command, we can see a comment. Comments in LaTeX are written with % symbols. The next three lines are metadata. We see the title command with the title LaTeX for beginners, the author command with my name, and the date command with whatever you want the date to render to. Finally, we get to the begin document line. And this is really where the material for your LaTeX document starts. Everything above it is called the preamble and is not actually going to show up unless you do something within the begin and end document environment to make that appear. For example, this make title command takes everything in your preamble that belongs to the heading of the document, like your title, author, and date, and renders it into your LaTeX PDF. For example, if we were to comment out the make title command and recompile our document, we would see that it has taken away that heading information. The next basic element of a LaTeX document are sections. And you can have as many sections as you want. To create a section, you type \section and then the name of the section that you're interested in. And you can see that LaTeX will automatically number the sections for you in the order that they appear. You don't have to worry about producing those numbers. You can also have subsections within each section. So if you type a \subsection, you'll be able to see that LaTeX will create a numbered subsection within the closest section above that command. This is where you're going to put all of the text that you're writing. So for example, let's grab some lorem ipsum text and insert it just to see what it looks like. All right, so what we see here is 2 paragraphs of lorem ipsum text. Each paragraph is separated by a blank line. It's important to have that blank line because that's how LaTeX knows that you're starting a new paragraph. If you take away the blank line, even if you have a carriage return, LaTeX is going to think that you have a single giant paragraph. This also happens if you have a comment. A comment line on its own does not do anything. And so if you have a comment separating 2 paragraphs, the compiler is going to think that's still one paragraph. You need an actual blank line with nothing on it to create a new paragraph. I mentioned this earlier when I talked about the begin document environment, but LaTeX has a lot of different environments that let you do different things within them. So let's get rid of some of our extra sections here. We don't need them. Let's start with one of the real strengths of LaTeX, which is math. We can create an environment by typing begin and then the name of the environment. In this case, we're going to start an equation environment. And LaTeX will autofill for you the begin and end. Every environment starts with a begin and ends with an end command. And the name in the bracket has to be the same. Within the math environment, we can type LaTeX formatted mathematics. I'm not going to go into the details here because there are a lot of good tutorials online for how to type LaTeX math. As you can see, LaTeX will automatically create this equation. Just like sections, LaTeX will automatically number the equations in the order that they appear. So you don't have to worry about numbering each one individually. Another environment that you're going to use a lot of is the figure environment. Now, Overleaf has provided me a bunch of content in here that I'm going to want as part of my figure environment. The first command just tells the compiler that I want the image centered on the document horizontally. The second command, the include graphics command, is where I tell the compiler where to find the graphic that I want. So within these curly braces, I want to put a reference to the file of the image that I want to include. In Overleaf, that image has to exist inside the project. So I can go to upload and upload a new file here. And thank you to Howard Senton from Unsplash for this image. I highly recommend creating a subfolder called figs that you can put your images into. That way you keep your Overleaf project nice and organized. So now we can tell the document that it can find our file at figs and the file name. And when we go to compile the document, we can see that now this figure appears in the document. This command inside the square brackets in front of the curly brackets allows us to define how wide the image is in the document. In this case, we're telling the compiler that we want the width of the image to be 50% or 0.5 of the entire width of a line of text. If we make it 1 times the width of a line of text, the image will be full size. Underneath the include graphics command, we have a caption command. And you can see that LaTeX has added this caption text underneath the image and automatically inserted figure 1. Just like equations and sections, LaTeX will automatically number your figures for you in the order that they appear, so you don't have to worry about that. Finally, we have a label command, and I'll talk a little bit about why this is important later, but this lets you reference figure 1 in your text. The last environment I want to cover is tables. Once again, an environment begins with a /begin command. And when I hit tab, Overleaf will fill in some important content for me. The first command inside this environment is just a centering command, which again tells the document to render the table centered horizontally. And then we have another environment within the table environment. Each tabular environment actually takes an extra argument. So here we have the normal begin and the environment name in the first set of curly braces. And then we have a second set of curly braces that defines the columns of the table and how we want them to appear. In this case, we have 2 letters, so that we'll have 2 columns separated by this vertical pipe. And the text inside each column is going to be centered because we're using the letter C. We can create another column if we want, and in this case, we can make the text in that column left justified, for instance. Columns don't have to be separated by these vertical lines. Each row inside the tabular environment is 1 row of your table. It's defined by columns that are divided by these ampersand symbols. A row is ended with these 2 backslash symbols. Let's create more rows. Press compile. And now we see that LaTeX provides us with our table. Just like in the figure environment, tables have captions that you can set. They also have labels that allow you to reference that table in the text. So let's talk about how you would reference, for example, a figure or a table inside your text. In this case, I have a /label command, and I'm defining the label as these words. It's convention, although not required, to begin labels for tables with tab : and labels for figures with fig : That just lets you separate the different types of elements that you might have in your text. Let's go back up to some of the text that we have and say that we want to reference figure 1 here. I could type, here I refer to figure 1, but like I said, LaTeX automatically numbers your figures and tables for you in the order that they appear. I don't want to have to go back and change that number every single time I update my document. And so instead, I can make this number into an argument, again, using a / command. And in this case, I'm using the ref command, which allows me to refer to my figure label. Now notice that this figure label in the ref command is the same as this figure label, these words in the label command. That's how LaTeX makes that link. And I can recompile and see that I still have, here I refer to figure 1. LaTeX only replaced the 1 for me here, not the word figure. So if you're going to use the ref, you still need to provide a word to indicate the type of element that you're referring to. Let's say I had a second figure and I wanted to refer to that one instead. Let's make a second figure real quick. I'm actually making a figure that doesn't have the include graphics command, just a caption. And this one I've labeled second fig. Now, if I go back and replace the label in the ref command with that new label and recompile, you can see that in the document, LaTeX has updated this to refer to figure 2, because that is the second figure. The same works for tables. This is how you can get these dynamic references. So no matter what order you put in your figures and tables, LaTeX will automatically number them in the correct order and then refer to them using this key. The last really important element that makes LaTeX so useful is bibliographic references. LaTeX allows you to manage your bibliographies really, really simply. To create a bibliography in a standard document, you need to insert 2 commands. First, you insert bibliography style and the name of the style that you want to use. You'll use plain, and then you insert the actual location of your bibliography. A bibliography is actually just another file, but instead of being a .tex file, it's a .bib file. And that's how LaTeX knows that this is a bibliography file that it should use for bibliographies and not a tex file that it should try to render. Let's go into that biblio file, which is totally blank, and put in some bibliography entries. I've just copied these bibliography entries from the Overleaf documentation on bibliographies. You can see that each entry has an @ symbol that defines the type of entry it is, book, article, or a proceedings, and then an open and closed curly braces that contains all of the elements of that entry. I'm not going to go into detail about how to create these entries because that's the topic for another video. The first element in each entry is the key. So just like before, when we used the figure key to refer to different figures, we can use the bibliography citation key to refer to different citations. Let's say I want to cite that first element, that book, in my document. I use the LaTeX command cite, and I copy in the key from this biblio file, and I can compile, and now LaTeX will create a citation for me, number it according to where it appears in the list of references, and generate that reference for me at the bottom of the document with the heading references. I can also put multiple citations into one cite command. So let's go back and copy another key, separate by a comma. And now you can see that LaTeX has reordered the numbers because the references actually appear in alphabetical order. And so the reference that I had written here first is actually the second reference in the bibliography. I'm going to comment out all of the extra elements here so that we can just look at the bibliography by itself. And you can see that now we have a references section with those two entries, and they are referred to in the text cleanly. This is a super powerful way of creating very flexible reference files that allow you to add and remove references very, very easily. The last trick I want to show you is what happens when you use a different class. So here we're using the class article, which is a basic LaTeX class, great for formatting homeworks or other basic documents. But sometimes you're going to do things that require you to use a particular class. If you are trying to publish a paper, you might get a LaTeX class from that publication. For example, IEEE Transactions uses the IEEE Trans document class. In this case, IEEE Tran changes the entire appearance of the document, but none of the content is actually different. So we have different appearing title, we have a different appearing heading, we have a 2-column format now instead of a single column format. The page numbers are in a different place, the references look different, but all the content that we provided is still the same. And that's really the power of LaTeX, that you can very quickly change the formatting without having to affect the content of your document at all. I hope that was helpful. This should get you started in creating basic LaTeX documents.